Hi, I'm Ali. Do you know what happens when you save a file on your computer? What about opening it? Well, today's problem is about that, and it is called Serialize and Deserialize binary tree. It's quite challenging, but we'll solve it together. And this problem has been mostly asked by Amazon and Facebook. So let's solve this problem together.
First of all, the question gave us the definition of the serialization, and then it says to design an algorithm to serialize and deserialize a binary tree. And it also said that there is no restriction on how your serialization or deserialization algorithm should work, but we just need to ensure that a binary tree can be serialized to a string, and this string can be deserialized to the original tree structure. So first of all, let's talk about these two concepts, serialization and deserialization, by an example. Assume that this is a binary tree that I have. Serialization is the process of converting this binary tree into a string. There are several algorithms that we can do this that I'll talk on the next section. And deserialization means to convert this string again to the binary tree. So for example, let's say this is our string that we made based on the suitable serialization algorithm. Deserialization means to convert this string again to this tree. So let me write them here. So serialize and deserialize. And on the clarification part, it said that the input-output format is the same as how LeetCode serializes a binary tree. And you don't necessarily need to follow this format, so please be creative and come up with different approaches yourself. So now let's talk about how LeetCode serializations work. LeetCode has a class called TreeNode, and with the implementation that we have here, for example, if we have an integer root, and if we call it x, in this class, if I call x.left, it gives me the left child, and if I call x.right, it gives me the right child. So consider that this node, which is the root, is 3 now. So the left child would be 4, and the right child would be 5. So this was just a brief explanation of how LeetCode works, but as you can see, there is a link to that. So if you're interested, you can learn how LeetCode serializes a binary tree in more details. And also it gave us two constraints. The first one is about the number of nodes in the tree, that is in the range of 0 to 104. And the node values are also between minus 1000 to 1000. Now that we understood the question, on the next section, I will talk about the suitable algorithm to solve this problem. First, let's talk about serialization. So we want to see how can we convert this binary tree into a string. I want to use BFS for serialization. And in order to do that, we need a queue and a string, which is the answer. And what we are going to do is that to put each node of this tree into queue, and when we add that into queue, we should simultaneously add it to a string. But the point is, we do not enter null nodes into the queue, but we add them into this string. So let's see how it works. We start from here. So first of all, we add 1 into the queue and also into the string. Then I pop 1 and put its child in the queue and a string. So its child are 2 and 3. And I also add them to this string. Then I pop 2. But as you can see, 2 does not have any child. So its children are null. But we do not add null into the queue, but we add them into the string. So we add 2 nulls in the string. Then we pop 3 from the queue and add its child. So we have 4 and 5, and then we add them into the queue and also into the string. Then we pop 4, and again, as 4 does not have any children, we put 2 nulls in the string, but not in the queue. And then we pop 5, And again, it doesn't have any children, so we add two nulls into the string. So with this simple solution, simple BFS solution, we have serialized this tree into a string, and this is the answer that we have. Now let's see how should we deserialize this string into a binary tree. Don't forget that binary trees can have 0 to 2 children. So again, like the serialization part, we need a queue, and we start from the first element of the string. We take the first element as the root of the tree, and then we add it to the queue. And like the serialization part, we do not add null values into the queue, and the algorithm stops when the queue is empty. Then we pop 1 from the queue and move index by 1. So it means that the left child of 1 is 2. Then again, we increment the index by 1. So the right child or second child of 1 is 3. Then we add 2 and 3 into the queue. And then we pop 2 from the queue and move the index by 1. So the left child of 2 is null, and I show null like this. And then again we increment the index, so the right child of 2 is also null. Then we pop 3 from the queue and again increment the index, so the left child of 3 is 4. And again we increment the index, so the right child of 3 is 5. And then we add 4 and 5 into the queue. Then we pop 4 from the queue and move the index, so the left child of 4 is null. Again, we move the index, so the right child of 4 is also null. And then we pop 5 from the queue and move the index, so the left child of 5 is also null. And then again we move the index, so the right child of 5 is also null. Okay, with this solution, we have deserialized this string into the tree, and as you can see, this tree is equal to the tree that we had at the beginning. Now that we understood serialization and deserialization concepts and suitable algorithms to do them, I will talk about the suitable code on the next section. First of all, let's talk about the tree node class that LeetCode gave us on the comment section. So as you can see, it has value left and right, and on the constructor it says the value of the node. And also at the end, LeetCode showed us how it runs the code. So it makes two codec objects, serialize and deserialize, and then first it calls the serialize function to build the string, and then it gives the string to the deserialize function to build the answer. Okay, now let's see the codec class. So we have serialize and deserialize methods, and serialize method is a string method, and it takes the root, which is a tree node, as an input. First of all, we checked if the root is null, we return null, and then we made the queue, like the algorithm section, and the string. And as you can see, our queue type is linked list, and that's because we can add or remove items in linked list with O1. Then we add the root to the queue, as you remember in the algorithm section, and then we also add the root to the string. After adding each character to the string, we add a space, because the string structure is something like this. For example, we have 1 space 2 space null, and so on. Then we have a while loop where the BFS algorithm is being applied to serialize the tree into the string. So let's take a look at this loop. The condition of the loop is while the queue is not empty, so it's the same as the condition that we had on the algorithm section, that we continued to add items into the string till the queue goes empty. So we pop each item from the queue and first check if its left child is null. We also add null and the space that I talked here to the string. And if it's not null, we add its left child to the queue and also to the string, and then we append the space. So for example, that here x is 3, and we pop that from the queue that we had here. We pop it from the queue, and then we check its left child. So because it's not null, we also add its left child to the queue and also to the string, and then append the space, and then we check the right child. So as you can see here, we check the right child. If it's null, we append null to the string, and if it's not, we also add the right child to the queue and also to the string and append the space. And at the end, we return the string, which is the answer of the serialization algorithm. Now let's talk about deserialization. So in this method, we want to convert this string into a tree again. So as you can see, it's a tree node method, and it takes the data, which is a string, as an input. First of all, we checked if the length of the data is 0, we return null, and then we split the data and assign it to an array of a string, which is called node. Then again, we make the queue, which is a tree node, and we make it with linked list again. And then we make the root with the help of the node. So we make a new tree node object and assign the first elements of the node array into that as the root. So if I want to show it on the algorithm section, this is the string that we have. First, we split this string into an array of a string and we split it by the spaces that we have, as you can see here. And then we made the queue. So this is the queue that we have, and then we assign the root from this string. So the first elements of this string is the root. And also we add the root to the queue, like here. So as you remember, I add 1 to the queue and then pop that. Then we have the index, but I mistakenly started it from 0 on the algorithm section, but we have to start it from 1 because the first one is the root and it doesn't need the index. So again, we have a while loop, and the condition is again while queue is not empty. In the loop, first of all, we pop each item from the queue, and then we check its left and right child. So if it's null, we add null to the left child, and if it's not null, we assign its value. And also we do the same thing for the right child. But let's see it with an example. So consider that x here is 1, and now we are checking its left child. So we see the node index, and the index is here. So we check if node index equals to null, which is not. We set it to null, but as it's not null here, so we assign the value that the index is pointing to that to the left child, and we also add it to the queue. And then we increment index by 1, so the new index will be here, and we check the right child. So if it's null, we assign the right child null, and if it's not, which is the case here, we assign the value that the index is pointing to that to the right child, and we also add it to the queue, and then we increase the index by 1 for the next iteration. And this is the work that this loop doing, and it does that until the queue goes empty. And at the end, it returns the root. Now let's submit the code in LeetCode.com and see the results. So paste it here and submit it. So it's been accepted. And now let's talk about time and space complexity. The space complexity of this algorithm is an order of n, because we save the whole tree nodes and also nulls, but because nulls are a product of n, I mean a product of number of nodes, so the space complexity is an order of n. And the time complexity is also an order of n because we access each node of the tree just once. So as you can see, the time and space complexity are the same as time and space complexity of BFS on a binary tree.
I hope you understood this important interview question. Also, if you like this video, consider subscribing and sharing it with your friends so we can help more software engineers to be prepared for their interviews.